And I'm going to start it now.
Hello, my name is T.L. Brink. I'm from Crafton Hills College in California's Inland Empire. The topic we have today is Statcato, which is a free statistical program. This was developed by a colleague of mine at Crafton Hills College, Margaret Yao, in the Computer Science Department. Together we are using Statcato, and we want your help in making this a better program. Let me tell you a few things about Statcato, this free statistical package that you can use at statcato.org. Statcato is a free program. There's no fees for licensing, downloading, or using. It is entirely free. It is also open source. It's Java-based, and because it is Java-based, it runs on multiple platforms. You might have a Windows computer, a Mac. You might be running Linux. You might be running the Google system for Chrome. It doesn't matter. Statcato works. Statcato has a number of features that make it really appealing for community college. There are some tutorials that you can use. There are even data sets that you can use as examples. The data sheet that you have to begin with uses a rows and columns format, just like Excel, just like SPSS. You use the rows for your individual subjects. In other words, the data coming from each case. Each column represents a different variable. You have a special row for the variable labels, just like you do in SPSS. One of the best things about the data sheet is a simple copy and paste. So one of the things I'll demonstrate for you is how you can take data already entered in something like Excel and simply paste it into the Statcato datasheet. Then we'll demonstrate some of the calculations. Simple descriptive statistics like mean, median, mode, standard deviation, skew, minimum, maximum. Then we'll show you different kinds of correlation coefficients that you can calculate. Of course, we have the parametric Pearson and also the non-parametric Spearman Coefficient. We then have several different ways to calculate regression. Simple linear, but also some different nonlinear techniques that you might find helpful. And then we have the inferential statistics, both parametric and non-parametric. Then there is the output window. This output window fills automatically as the calculations are done. And once the data appear in the output window, they can be edited directly. You can also type in little notes to yourself. You can then take that entire output window and you can copy and paste it into a Word file. Then there are the charts that this Statcato can demonstrate. Bar charts, pie charts, box plots, scatter plots, and more. So what we'd like to do at this point is to show you Statcato. This is what Statcato looks like. You just go to the website, download it, run it, and this is what you have. Let's start right here with the data entry sheet. Notice we have the rows, that are numbered consecutively, one row for each case. And again, you have the columns, and each column represents a different variable. Now you can enter your data directly on the Statcato. For example, I'm going to go to this first column, column 1, and let's suppose that column 1 is for gender. Okay, we're going to ask the question, is the subject a female? And I've just hit the arrow key to enter that. And we're going to code that 1 for yes and 0 for no. Suppose our next variable is going to be age. And we'll type in the person's exact age. Let's suppose our next column is whether the case has been diagnosed as suffering from depression or not. And let's suppose column 4 is whether or not the patient was prescribed medication. And let's suppose column number 5 is whether the patient received psychotherapy. And let's suppose column number 6, variable number 6, is whether or not the patient has had improvement. And we'll measure improvement on a 0 to 10 scale, with 10 being the greatest possible improvement. So we use the arrow keys to move around, and we can enter the numbers either from the top column on the keyboard or from the little data pad over on the right. Our first case is a female, so we'll type in 1. She happens to be 35 years old. She was diagnosed as depressed, so that's yes, that would be a 1. She's been placed on an antidepressant medication, so that's yes. She has been assigned to psychotherapy, so that's a yes. And after 6 weeks in the program with the combined treatment, her improvement rate is a 7. Let's suppose that our second case is a male, so he would receive 0, meaning no, he's not female. He is 42 years old. He was not diagnosed with depression. He was diagnosed with something else, so we'll give a 0. He was not placed on medication. He was referred for psychotherapy. His level of improvement is only 2 after the 6-week trial. So this is how data would be input directly in the Statcato. Now, if you find it easier to use a different technique, you can. So right now I'm going to erase what we have so far, and you can erase it just like you do in Excel by hitting the space bar, hitting the backspace, hitting the delete key. All of these things are capable of deleting. Now here's an Excel file that I actually developed for one of my students' presentations at the Western Psychological Association. This presentation was done on parental favoritism, and the student was Melissa Clabe. So right now I've highlighted in Excel the names of the variables. And I'm going to go back in the Statcato, click right here, and use a simple paste function, and the names of the variables are being pasted right into Statcato. So here we asked, was the patient male? Yes or no. Is the patient over 25 or under 25? Yes or no. With birth order, is this the oldest child, the youngest child, a middle sibling, an only child? And this variable is the current relationship with siblings. Excellent, good, fair, poor. So that's a 1 to 4 scale, with 4 being excellent, 1 being poor. Current relationship with father, current relationship with mother. And then these two columns represent, did the father favor one of the siblings over you? 4 would be definitely, 3 probably, 2 possibly, 1 not at all, and the same question for the mother. So we've input our columns, our variable names. And now let's go back into Excel, and we're going to look at the rows and the columns that we had for our data. And we're simply going to copy that, go back into Statcato, click on row 1, column 1, paste, and we'll see if it pastes in. Yes. And we're going to check to make sure that all the data were copied correctly. And we had a total of 45 cases. And indeed, all the data were correctly entered. So that's how we do the data entry. Now let's take a look at some of the calculations here. We can start with basic statistics. Let's do some descriptives. And let's input all of our variables, column 1 through column 11. So we're going to go C1 C11. And we could have picked specific variables if we wanted. And let's look for a mean. Let's get a standard deviation. I like medians. Let's also get a minimum and a maximum. And let's get skewness, unbiased. Okay, let's see what it gives us. It gives us a nice little table where we have the mean of each variable and its standard deviation. And of course, when we had zeros and ones, that's really a percent. Like 49% of our subjects were male. 11% of our subjects were over age 25. And then, of course, we have our medians. We have minimums and maximums. I like to do these at the beginning just to make sure that all the data entered are within the specified range, and they appear to be. And here's our skewness calculations. So all of this is right here in our output area. Well, let's now do some correlations. Let's see what we have. We could do linear correlation with two variables. That would be a Pearson. I prefer Spearman's because some of these are really ordinally scaled rather than true ratio scaling. Let's use a Spearman coefficient. Let's try to see which variable of the ones we have here is the best predictor of whether or not the mother showed favoritism, or at least whether the subject perceived mother favoritism. Okay, so we're going to select that variable. And we're going to see if that relates to whether or not the individual is a male. So we'll add that variable. Let's try it again and see if age is a predictor. And let's see. Let's see if being a middle child is a predictor. And let's see if current relationship with siblings is associated with perceived mother favoritism. And let's see if current relationship with the mother is a predictor. So we click on OK. And once again, our output box fills automatically. So let's look through that output box and see what we found. Okay, I'm going to focus on the p-value. Notice how it automatically calculates the p-value. And it appears that there is absolutely no correlation between whether or not the subject was male or female in perceived mother favoritism. Well, let's see if there was any correlation with age. Nothing there either. And what about middle child status? Well, that's kind of almost a weak positive correlation, but it's really not statistically significant yet. It doesn't approach the 0.05 level. What about current sibling relationships? We have a correlation here. And this appears to be an inverse correlation. In other words, the more perceived favoritism on the part of the mother, the poorer the current relationships with siblings. Now, it's not quite statistically significant yet, but it's getting pretty close. What about current relationships with mother and perceived mother favoritism? Once again, that's an inverse relationship, but not statistically significant. So you can see how we look at these things. Now, if you wanted to make some notes here and say that this is a trend but not significant, you can type right in there and it will save that information. And if you wanted to try for some kind of non-linear relationship, well, you could do that too. Let's take a look here and see what we would do there. Let's take a look at correlation and regression. Let's click on non-linear models. Let's try something polynomial and see what happens. We're going to select the dependent variable of, we'll make current relationship with the mother our dependent variable. And we'll try to predict that by looking at the relationship with other siblings at the present time. And we'll see what happens there. And it even shows a little plot. Doesn't appear to be much of a relationship there. Then we can also do some graphs if we want. Bar charts, box plots, dot plots, histograms, pie charts, scatter plots, stem and leaf plots. We have a lot of possibilities for all these variables. So that's what we can do here. And let me show you how easily we can paste this output into something else. So you can open up, say, a Word document and just sort of create a new document there and paste it right in. I'll just paste it right on this existing document. I can paste all of those materials, and I can paste the output box. So let's go back into the output box. I can select everything, copy, get back into my Word document, paste it right in there, edit it, put it in any kind of Word document I have. So those are some of the many interesting features of Statcato. And let's now stop sharing that content, and we're going to go back to talk about what I would like from you at the present time. I would like to know, what else would you like to see in Statcato? Would you like to have it more web-based? Would that be a help? What other kinds of statistics could we have? Look at the variety of parametric and non-parametric statistics we have. What else would you like to see? Would you like to see structural equations? Would you like to see a Bayesian approach to handling statistics? We could work on that. Whatever you'd like, let us know. Our mission is to create a great alternative to the expensive statistical packages that are out there now. Contact me, TLBRINK, at graftonhills.edu, or contact Margaret Yao, MYAW, at graftonhills.edu. We look forward to hearing from you.